All right, guys. So in this video, we're just going to do a bunch of practice problems for drawing different Lewis structures. All right. And so what I'm showing you here is your rules that I went over at the end of the last video for drawing the Lewis structures. So we'll just have those up there for reference as we kind of crank through this. And so, all right. So the first one that I wanted to do was hydrogen fluoride, or hydrofluoric acid. If it was dissolved in water, we call it hydrofluoric acid, right? And so how would we do this? Okay, so first we need to count the total number of valence electrons, right? And so we know that hydrogen has one valence electron. Fluorine is a halogen. The first halogen has 7 valence electrons. And so we're gonna have 8. And I'm gonna write this as V electrons, okay? Standing for valence electrons. So it's 8 valence electrons. Okay. Now it says write a skeletal structure arranging atoms around the center atom. Least electronegative is the center. Okay, well, there's only 2 atoms here, so there's no center. So the skeletal structure just looks like H and F, just next to each other, because there's no center. You're only gonna have a center if there's at least 3 things, right? So there's no center, just one on each side. Now, use a pair of electrons to form bonds between the atoms, okay? That's going to be a line. So that represents 2 electrons. Now we're on step 4. Use the remaining electrons to complete the octets for the outer atoms and duet for hydrogen. So hydrogen, let's think about this. Hydrogen needs a duet rule. It needs 2 electrons. So there's already 2 electrons for hydrogen, 2 on the bond. So hydrogen's good. And now we need to form an octet. So we've used up 2 of our electrons. 2 of our electrons are counted for. 2 electrons in the bond, right? And now we're gonna have to complete the octet for fluorine. So we're gonna put 6 electrons. There we go, sorry for that. 6 electrons around fluorine. And so 6 electrons are lone pairs, okay? So we had 8 valence electrons to work with, right? 8 to work with. 2 were in the bond, and 6 are in the lone pairs. And let's check. Duet rule satisfied, we already talked about that. And is the octet rule satisfied for fluorine? 2, 4, 6, 8 electrons fluorine has, so yes. So this is the complete Lewis structure, and we're basically done. We didn't have to go to step 5 and form a double or single bond. All right, so that's nice. Let's now do another one. Let's do nitrogen. Nitrogen, okay. Actually, let's do, I want to start with, we'll do nitrogen in a second. Let's do methane. All right, methane. Count the total number of valence electrons. All right, well, carbon is in group 4 as 4 valence electrons. And we have hydrogen, we have 4 of them though. Hydrogen is 1 valence electron, it only has 1 electron total. So total again is 8 valence electrons. Okay, and so now we have to make a skeleton. And our least electronegative atom, well, what are we comparing against? We're comparing against hydrogen, and it says hydrogen is always the end atom, terminal atom, because it's duet, terminal atom, because it's duet rule. So carbon's going to be in the center. So we're going to set up something like this with the hydrogens around the end. And now the third rule says draw lines to connect them all. Okay. Well, now we have to do rule 4, which is duets for hydrogen. All the hydrogens already have duets because they all have lines to them. They have 2 electrons each. And now we need an octet for carbon. Well, carbon has 2, 4, 6, 8. So we're already done for carbon. Carbon's done. And we used 8 valence electrons. And there they are, 2, 4, 6, 8. They're all in bonds. But that's the Lewis structure of methane. There's no lone pairs. Okay? So that's that one. Pretty straightforward. Now let's do 2 more. in this video. Let's do nitrogen. Nitrogen. All right, nitrogen is a group 5 on the periodic table. So that's going to be 5 valence electrons, but there's 2 of them, right? So 5 times 2 is 10. Okay, so we're going to have 10 valence electrons. There's no center atom, so I'm just going to put nitrogen and nitrogen. I'm going to draw a single line, and now I'm going to try to do the octet rule. And so the best way to do this is, nitrogen just has a duet, nitrogen has a duet. They only have 2 right now. We don't want that. We want octet. So a nice thing to do this is just break up the electrons evenly. So I'm going to put 2 here, 2 there. Okay, I've used 2, 4, 6 at this point. I have 10 total. So I'm going to have 4 more, 2 there and 2 there. Now I'm maxed out on electrons. I have 2, 4, 6, 8, 10. Okay, I'm maxed out. I can't add any more electrons. Okay, and let's check. Do I have the octet rule? No, I don't. 2, 4, 6 for this nitrogen. 2, 4, 6 for this nitrogen. So I have 6 electrons, not octet rule. Okay, so if you run out of electrons for the octet rule, form double or triple bond. Okay, so what I'm going to have to do here is I'm going to have to erase one of these lone pairs, and I'm going to have to change that into a double bond. Okay, and now let's see if I've satisfied the octet rule. Let's see this nitrogen. How many do we have? We have 2, 4 in the lone pairs, 6, 8. That's good, octet rule. This one, 2, 4, 6. Uh-oh. Again, I can't add any electrons, right? And I don't have an octet rule here. I only have 6. So what do? I'm gonna have to form a triple bond, okay? And so I'm gonna erase this lone pair, and I'm gonna turn that lone pair into a bond. And now let's do the counting. Well, I have 6 in the triple bond, and I have 1 lone pair. That's 8, octet rule satisfied. And I have 6 in the triple bond and 1 lone pair. That's 8 for this nitrogen. So nitrogen has a triple bond. All right. And so let's do one more here. Let's do CO2. Okay. CO2, count the total number of valence electrons. Carbon is group 4. Oxygen is group 6, and there's 2 of them. So that's a total of 16 valence electrons. Least electronegative atom in the center, that's carbon. Carbon's to the left of oxygen on the periodic table, so it's more electropositive or less electronegative. So carbon's going to be in the center, and the oxygen is going to be on the sides, on the ends. Now we draw the single lines, and we're going to go through and try to use up all of our electrons to complete the octet rules. So let's see. Again, the best way here to start out is just to evenly spread them out. So I'm going to put 2 here, put 2 there, and 2 here. Evenly spread them out. I've used up so far 2, 4, 6, 8, 10. I have 16. So I'm going to be able to put 6 more, evenly spread them out. Now, 2, 4, 6, 8, 10, 12, 14, 16. I'm all up, used up. I've used 16 valence electrons. No more electrons available for bonding. Do I have the octet rule satisfied? Let's look at carbon. Carbon, 2, 4, 6, 8. 4 in the bond, 4 in the lone pairs, 8, octet rule satisfied. Carbon's happy. Oxygen, 2, 4, 6. Uh-oh, there's a problem. Oxygen, 2, 4, 6. Both oxygens are missing one, and are missing 2 electrons. And I can't add any more electrons. I've used all of them up. So what do? We do just what we did before. We're going to form a double bond on each of these oxygens here. I'm going to erase these lone pairs and draw it like this. Okay. And let's see, if we did it like that, is that right? Now look at carbon. Carbon has 2, 4, 6, 8, 10, 12. No, that's not octet rule. It's way too many electrons. And oxygen has 2, 4, 6, and oxygen has 2, 4, 6. So I messed up, right? So I don't want those like that. Again, I had 16 valence electrons. So and I was in this situation here, so instead, what do I need to do? I need to move these lone pairs on a carbon and use those. Okay. Like that. And now let's check. Carbon, 2, 4, 6, 8. Boom. That's octet rule. Satisfied. No lone pairs. Oxygen, 2, 4, 6, 8. And this oxygen is the same. 2, 4, 6, 8. So that's my final answer and done. So we'll do some more practice on this. This is really important, guys, to know. So we're gonna really crank through a lot of practice.